base 4 is z plus 2 log base 4 of y minus 3. There's two things you got to know. You got to know what to do with the factors in front of a logarithm. So I'm going to write this rule backwards from what's on your form quiz. If you have some r times a log with an argument of a, where's the r go? Exponent. Some of you know that, some of you don't. Just where it goes. Some of y'all are guilty of asking why too much. Don't ask why. Don't ask why until you're old enough to actually understand. Not on this stuff. So anyways, you move that r up top. The other thing we talked about that, of course, there's condensing rules for all that stuff, but you can also think about it in words. If the argument of a logarithm is positive, if the logarithm is positive, where do you put its argument? Log is positive. Where do you put the argument? Numerator. That's right, Aniston. Place the argument in the numerator. Just going to write hand you out. How I feel. You can go address that. What if it's negative? Denominator. Most of y'all know that, some of you don't. Three of those pieces are really easy to fix to get ready. You got a 2 log base 4x. Where's the 2 go? So any numbers in front of an existing logarithm you can move pretty quick. Just by following that property up there. That's going to become an x squared, a z cubed, and a y minus 3 all squared. What do you do about that 3? It's not a logarithm. 3 is not a logarithm, is it? What can you multiply anything by and not change its value? 0. 1. 1. Multiply anything by 1. This is log base 4. Log base 4 of what is 1? 4. I've been over that with y'all half a dozen times. That says what power of 4 creates a 4? Answer, that's 1. So can I take that 3 and multiply it by log base 4 of 4? Yeah. Why? Because it's 1. It doesn't change the number. It changes appearance. Kind of like false advertising. It's not really a 3. Or sorry, it's not really a logarithm. It looks like a logarithm. It doesn't change it. Log base 4, 4 is 1. You do not change the number. Change the way it appears. Now where's that 3 belong? Exponent. Now you're ready to condense. You're going to have one logarithm. You're going to have a lot of stuff inside of it. What's its base going to be? What's the base of all the logarithms up there? So your new logarithm is going to be a base of 4. It's going to have a numerator and denominator. If the original logarithm was positive, where does its argument go? Up top. So the first thing I see is log base 4 of 4 cubed. Is that logarithm positive? So where do I put 4 cubed? Numerator. Obviously, we'll clean that up. What else do you see that's positive? X squared. That logarithm has a positive sign in front of it. Anything else? That's all the positive logarithms. There's only one negative logarithm. What is it? Z cubed. Where does it belong? Denominator. Oh, there's only one thing to fix. Nobody would leave 4 cubed. Nobody would. Unless you just don't know where it is. What's 4 cubed? 64. When kids do funny things like that, when they leave numbers like that, that basically tells me you don't know anything. 4 cubes and 64 forever. It'll always be 64. In fact, you're supposed to memorize that. So there's your review on condensing logarithms. Underneath that's a problem we're going to do without graphing. What interest rate is required to quadruple an investment in 4 months if the interest is compounded continuously? You need a formula. PERT. You saw continuous and you associate it with PERT. Amount after time passes is the principal times E raised to the RT. When you're dealing with money problems, time is always measured in what? Compound interest formula where you had to figure out the value of a car loan. How is time measured? Years. When you're dealing with money, time is always in years. There's a couple ways of doing this. If you want to change into months, you can put it T over 12, but you don't have to. 4 months is how much a year? Third. I don't know what you said, but it's third. It's 4/12ths of a year, isn't it? It's a third of a year. You just got to make sure you stick with years and units, or you got to change the equation to have months. We're just going to keep it in yearlies. We're going to make it a third of a year. How much money you want to invest? $1. We've done that a couple dozen times. What's it going to become if it's going to quadruple? $4. So after time, after that third of the year has passed, you now have $4. That's everything you need to plug it in, because if you plug that in, there will only be how many unknowns? 1. That's the goal of any singular equation. Right, 1 unknown. Don't know what R is. You made time a third of a year. What do you want to do with it? Well, that one's correct. What can you turn into? Turn into a logarithm. What's its base? E. What's its answer? What's its exponent? Third of R. That's right. Log is what? Okay. It becomes a logarithm. It's a log whose base is E, which we'll worry about in a second. Its argument is the old answer, 4, and it equals the old exponent, 1/3 R. If you want to write R 1/3, go ahead, but it looks better. Log base E. Even on those old calculators, you can look at them. Log base E what is what? What is it? ln. Look where you find the E on that keypad. It's on what key? ln. It's a natural log. Oh, by the way, the reason those calculators are out and the nice ones you put up is because there's actually 4 of them that are missing. Those things are over 200 apiece. You don't get the nice stuff unless I get it back. Those will do the job though. I don't really care about those. I care about the ones that I had. I want those back. You got a third there in front of the R. How do you fix that issue? Times it by 3. Because a third of 3 is going to be a 1. They'll cancel each other out. That is going to be your answer. If you want to know what it is, what do? Put it in a calculator. You can do that on yours. It's still got an ln key. Nothing changed. These don't have color. There's some other little features the new ones have that some of y'all have discovered that I haven't talked about. But you can still type 3 ln 4. That's a decimal, 4.1589. What's that look like as a percentage? There you go, 415.89%. You got to move that decimal 2 positions. It's a pretty impressive rate of interest. I believe they could just shut up and take all my money. If you invest $1 at the end of the year, it's 64. Because that's happening every 4 months, isn't it? Every 4 months, that's the interest rate. Pretty impressive. All right, on to today. Baby. It says 8-4, multiplying and dividing rational functions. The prerequisite skill is simplifying things. You used to do this in Algebra 1, but they took it out of Algebra 1 a couple of years back. When you were in middle school, you actually learned how to do this. 15/65. What's the common factor of 15 and 65? 5. You know, the teacher probably wrote down that this is obviously 3 times 5, and 65 is 13 times 5. Should be. They said you can cancel those 5s out. That's the property you were taught. You weren't actually taught properties like this, but you were taught how to do that. The C here stands for common factor. So you have A times a common factor over some B times a common factor. What can you do with those common factors? Then we cancel out. Say over B. All common factors cancel out. Now, I've done this for a while, and I see kids do a lot of weird things. Kids do funny things. Kids will take this little property and they will expand it into things that don't exist. There's no property for simplifying things when there's pluses or minus symbols. That property doesn't exist. This property is about multiplication, isn't it? A times C over B times C. Usually the kids who screw up this property happen to be the kids who can't factor. The two are highly related to each other. If you can't factor, usually you just take this property and just murder and stab it to death.
Pardon this interruption. I did send out an email just a few minutes ago. When you get a second, please check that email.
Now, another easy example on this page down at the bottom, it's 4 times x plus 3 over x minus 5 times x plus 3. What is x plus 3 to both the numerator and the denominator? It's a common factor. The symbolism between the 4 and the x plus 3 is multiplication, isn't it? Anyone understood multiply here and there? That's the stuff we can cancel out. The multiplication is involved. X plus 3 over x plus 3 cancels out to become what understood number? 1. The 1s aren't written because they're understood. This is down to 4 over x minus 5. The next thing in your notes is just a slide there to help you remember what you're not supposed to do. So in your notes, you'll see this nice little fuzzy, warm-looking kitten there, the ginger cat that nobody cares about because it's a ginger. No offense, gingers. Yes, ma'am. I can't tell you how many times I've watched kids do this. What's the problem? What's in between the terms? Addition. There's no property for canceling out addition. There's property for canceling out what? Multiplication. There's no property for addition. And I see kids do this all the time. Kids who think they're smart do it. So before we do example 8 correctly, let's do what the kitten killer would do. What would the kitten killer do with x squared minus 2x minus 3 over x squared minus x minus 6? The kitten killer actually usually does a lot more. There's a kitten killer and then there's like a serial kitten killer that I've observed. The guy who just wants to kill one orange cat does this. Then you've got somebody who has a vendetta against cats and they do that. I've seen it. Doesn't make a lick of sense to me. But it comes from the idea that we're teaching you to cancel out things that are common, doesn't it? But it's only for what symbol? Multiplication. It's not for addition or subtraction. Don't be a kid killer. So, how do you handle example A? What do we do with 15 over 65? We factor it, didn't we? So what do we got to do with x squared minus 2x minus 3? We're going to factor it. You know, I know it's so depressing. You have to factor to see what's coming. So if you think about reversing the FOIL method for that trinomial up top and that trinomial on the bottom, what's it take to create the x squareds? X and x. Don't know how to FOIL? I suggest you get on YouTube and watch some lessons on how to FOIL it. Takes an x and an x to create that x squared in the numerator up top. Next, I would worry myself with factors of what number? 3. These aren't bad. The only way to make a 3 is a 1 and a 3. What do you want to add to? Or up top in the numerator. What do you add to in the numerator? -2. Well, how do you arrange a 1 and a 3 so that you add a -2? -3 plus 1. Numerator's factored. Time to factor the denominator. What's it still going to take to create an x squared? X and x. Now worry about that 6. What's it take? 2 and 3, 3 and 2, however you want to write it. To add to a -1, which one's negative? 3 is negative, the 2 is positive. Now, before you actually simplify, notice it says state the domain. Do that before you simplify. Because once you simplify, it won't be there anymore. As soon as you simplify, something always disappears. What's the second commandment in mathematics? Can't divide by 0. Over there. Ten commandments in there. It's incredibly sacrilegious, especially since I'm Christian, but I don't think God's going to care about that. It's not like it says somewhere up there, y'all shall have no other math teachers than me. Does it say that? Doesn't say that. Anyways, can't divide by 0. What would x be to make that factor of 0? Not 2, -2. There's no way x can be -2, because if x was -2, what would you be dividing by? 0. You look at that second factor in the denominator. What makes a 0 at x minus 3? 3. Either one of those things create zeros where you don't want them. And the reason I'm saying you have to do that now is because you're about to do something with x minus 3 over x minus 3. What are you going to do with them? Cancel them out. Most of us only like to look at the last thing you wrote. If you only look at the last thing you wrote, what's it suggesting the only thing x could not be? That's what it's suggesting. That's why you do it there. All right. Move on over. Part B. Before you can cancel things out, what do you got to do? Factor. If you can't factor, start trying to do the homework. Maybe you'll figure it out. All right. 2x squared plus 10x. What can you pull? 2x. I have no idea where the 5 came from. 2 and 10 are both divisible by what? 2. Both of them contain what? X. If you pull 2x from 2x squared, what's left? X. If you pull 2x from 10x, what's left? 5x. Top's factored. I don't know why I have the x. Thank you. Bottom, a little harder of a trinomial to factor. What's it take to make the 3x squared? And x. That handles 3x squared. The next thing on your mind is the 5. How do you want to make a 5? 1 and 5. And the order that was suggested is perfect. You're supposed to know how to FOIL. What would the outside make? 15x. What would the inside make? And what's the goal? 16x. There's a 16 in the middle. This did the job, didn't it? Plus plus. Anything plus plus always factors as plus plus. Always. Now, before we simplify, what should we find? Domain. This one's easy. What value of x makes a 0 at x plus 5? Negative 5. All values of x such that x cannot be negative 5. This one, I don't know, probably 20% of junior class couldn't figure it out. It's pretty bad. I know it can't be 0. I say it's not 0. Then you do 2 steps. Subtract 1 divided by 3. What can't x be? Negative 1/3. Possible. Problem is fractions. Problem is copying. Problem is cheating. Problem is calculators. You guys look at those calculators, you're like, I can't do anything without a calculator. Who made a calculator? A man or a woman, just a man in general, made the calculator. You can do it, kids. Listen. Yeah, you look like you need to poop. Go. You look like you had some stomach discomfort there. What can we cancel out the top and bottom now? X plus 5. There's your simplified result. Funny thing is, I'm recording. I don't care. Nobody's gonna watch it. Like 42 subscribers. Who's gonna watch that? At least one of them's a parent. I know that for a fact. Anyways, would you have seen the negative 5 in the final answer? No, it wouldn't have. It wouldn't be there. Oh, we still got enough time here. We can do multiplying rational expressions. You actually learned this also in middle school. You didn't do it with algebra. You didn't do it with x's and y's and stuff like that. But I know full well that you learned how to do something like 5/4 times 2/3. You did, didn't you? What do? You multiply 5 by 2, and you multiply 4 by, and then you reduce. 5, 6, and 7, 9, kids. The property here that you learn is simply top to top, bottom to bottom. That's all you learn. Of course, you always simplify. I didn't reduce 10, 12 because it's an example, but you always simplify. This example is easy, so don't think they're all this easy. I wish they were, they're not. This one is. Most of the time, you have to factor before you do anything. This one doesn't have anything to factor, does it? So you just do the multiplication. What is a 5x squared times a 6xy cubed? I agree with 30x cubed. 5 times 6 is 30. And x squared times x is x cubed and y cubed. Bottom to bottom. 2xy squared times 10y. Yes, ma'am. Now, is it simplified? No, not even close. 30 over 20. 3 halves. Cancel out the zeros. I'm sure you learned that lesson. X cubed over x. Where? Top. Y cubed over y cubed. 1. Understood. God, it'd be great if they were all that easy. None of them were that easy. It was a learning exam. My guess is the next one we have to do involves factoring. What do you want to bet?
Let's just not do it.
Let's just go ahead and do it. The more I do today, less I have to do with y'all another day. And the example here says factoring and simplification should always be the first thing to do. It should always be the very first thing to do. Because if you factor and simplify in the beginning, it's less work to do later on. Do not be the kid who does 2x squared minus 10x times x plus 3. That kid never gets anything right. Be the kid that factors. How do you factor 2x squared minus 10x? 2x times x minus 5. She pulled a 2x from both pieces. Down low, x squared minus 25. That's a special pattern. That's the a squared minus b squared pattern. That's right, Alex. Don't believe me? Boil it out. There's absolutely nothing you can do with x plus 3 over 2x squared as far as factoring goes, because they're done. Now, before you finish, go ahead and take a shot at domain. What can't you divide by? There's 3 things x can't be. The tough one, which is the easiest one. You're going to want to hit yourself after I tell you what it is if you don't figure it out. 0. I told you you're going to want to hit yourself. So the 5 and the negative 5 came from that factorization on the first fraction. The 0 came from 2x squared. Because if x was 0, what would that piece be doing? X was 0. So that's one things you can't beat. And we may not see that when we're done. What can be chunked on the first fraction? X minus 5 can be chunked. You may not see it, but there's more. Is there a 2 up high and a 2 down low? Is there a multiplication symbol in between those things? I hope you see what I'm talking about. But there is a 2 up high and there's a 2 down low. There happens to be a multiplication symbol in between the 2 fractions. You can always cancel out common factors when there's multiplication. Is there anything else you can do? The x and the x squared, that's right. You can throw away the x up top and change the exponent here to a what? A 1. Which is understood. And look how much easier that got. You threw away the entire numerator of the left fraction. It's just an understood 1, isn't it? So 1 times the x plus 3 in the numerator is going to be x plus 3. The bottom is going to be x times x plus 5. And here's a nice little thing about the way we do these things. You always leave the numerator, sorry, not the numerator, the denominator. I'm just going to erase that and retype it, rewrite it. Always leave the denominator factored. Always. No worries about it. You leave it factored. You don't have to distribute the x. It's good enough. That's a better starting point.
Yeah.
Not what you wanted. It's what you got. And if you did happen to walk off one of my nice TI-84 color editions, I'd like it back. No questions asked. I just want it back.